And that looks like it's upside down, so I'll write it. Okay. Go ahead and minimize this. You said you had a question? We did do 3-2. You said you had a question on it?
Okay, so it's saying today, 3-2 is due by tonight.
It should be due 2 days from today on Thursday.
Oh, because it's saying here,
Because
3-2 should be.
it should be due, because you should be able to ask questions today. You should have been able to ask questions last Thursday, but I wasn't here.
Mhm.
So you can ask questions on it. 3-2 will be due 2 days from today. Is that the only question you had?
So and then if you got 3-3.
So we go, watch. Where's Blackboard?
Yeah, I had that same problem as well.
Hold on, all I gotta do is fix this up. Let's, Blackboard. Oh, I know where I go. Yeah, inside Blackboard, so. I wanna go into the class. Do you know why this comes up? Did I tell you, explain why that happens? This guy up here, the pop-up blocker is turned off. If it was turned on, this wouldn't pop up.
Hmm.
Let me minimize that, get it out of the way. Let's take a look at the assignments. Now it is due Thursday. I'll just shift them all back a day. That should also be on the 13th then. Where'd the syllabus go? So now, today I plan on doing 3-3. So 3-3 will be due 1 week from today on 2/13. We pop over to Alex. 3-3 will be due on 2/13, and it is good. Now let's see what else we have here. Then 3-4 we cover on the 8th. Oh, no. It's just on the 8th. Yeah, on the 8th. It'll be due on the 15th. So 3-4 will be due on the 15th. Got it. Apply. 3-6. Let me check it out in a second. 3-6. Is it right here? 3-6. We would cover that on 2/13, so it'll be due on 2/20. 3-6 will be due on 2/20. And then the last topic will be due on the day of the test. So these two things here will be due the same day as the test is available, which would be on 2/20. And I think that's right, correct? Does it say 2/20? Yeah, okay, it's good. So we're fixed then. I have to go, these exams are not my making, just so you know. Just do homework right now. I'll put up new exams of my own later on. All right, so hopefully we got this fixed up. Do you guys have any questions on the homework? Any problems you'd like me to do?
1, 2, and Thursday.
Are you okay?
Yeah.
What's that paperback that you got there from the school? Is that tutoring from 955?
Yeah, I just stopped in there and talked to Don.
Can I see it? Let me show everybody what it is. Okay. This is, no, this is not you. See that?
Well, at the top, he said, he asked me what I was thinking. I told him to get us down. He said you were.
Okay, yeah, but this was specifically sent to the 0910 folks.
Okay.
But yeah, obviously tutoring, do you know where it's at? 1108? Oh, that's right. They got a special thing around here now too, don't they? So what do I know? I don't know. I used to know what the tutoring was.
You trying to be, you two, we-
3-2 is due on 2-8. Now, if you look, I want you to notice something here. I allow you to do late submission for anything. So like this one here, I made a mistake when I did it. When I come in here and I look at it, I should allow a late submission of May 9th. So what you do, it doesn't, I don't know why it doesn't show that on there.
It showed me today.
Did it?
Yeah. It said 10% off.
10% off, that's right. So let me see here on 3-2, 2-8. This should show. I don't know why it's not showing that. But it's 10, basically, if you don't do it on time, anything you turn in late will be deducted 10%. So as an example, I'll give you, does it turn into open after I, no, it didn't. Oh, you know why? It says, because it's not late yet. But these will be open throughout the rest of the semester. So I'll give you an example of how many points. Let's say you have a homework assignment of 100 questions. And for whatever reason, you only do 90 of them. You hit submit. Make sure you hit submit before the due date, so at least it takes, okay? You hit submit, then you get 90 out of 100. Then later in the semester, you go and you do the last 10 questions. You get them all right. You'll get 90% of those credits. You get 9 out of 10 points that's left over. Understand? So even being late, it could be 99 out of 100. Additionally, the entire homework assignment collection is worth 50 total points. This class is worth 650 total points. So it's less than 10% of the grade. So any single test, any single homework is less than 1% of your grade. That's the entire assignment. So I'd say the question is worth minuscule amounts. I just wanted, somebody mentioned that I didn't put on the syllabus. I don't normally put that on stuff on the syllabus. They're usually, you'll discover it when you click into it. You know, what those things are. And you say, it shows you, right? You guys saw the 10% deduction. All right. No questions, then I will go on with our new syllabus, which then what are we doing today on the 6th? Applications of linear equations. Applications, do you know what that word always means in mathematics? Word problems. Everybody's favorite. So let's pop into Alex. And there's generally three different styles of problems that they key on. So I'm going to go into here. I don't want to go to the homework. I want to go into the book itself. See something. For whatever reason, mine comes incredibly sized. I don't know why it does that. Does yours do the same thing? I have no idea the purpose of that. But I'm interested in the styles of problems down here. All right, so the game plan is this. We are just going to do, I'm going to do the different styles of word problems. They have similarities, that's why they're all grouped together here. But there will be several different types. I'm going to do a new page for this. All right, in the early stages of the word problems, we try hard as we can to use one letter to represent several quantities at once. Let's take a look at this as a perfect example to start. What you have to do is whatever you're being asked, you typically want to assign it some sort of a letter. So let's see what we have here. We have Bolin has applied to 3 more colleges than his sister Lilling. Together, they applied to 13 schools. How many colleges did each apply? So what we want to do is we want two answers. Do you understand that they're looking for two answers here? Now remember, this stuff will be uploaded. So Bolin applied to 3 more colleges than his sister Lilling. Together they applied to 13 schools. How many colleges did each apply? So let's break this down. They're asking us for how many quantities here? Each one. So they want to know how many schools Bolin applied to and how many schools Lilling applied to. You follow me? So if they're asking me, oh, I would like to know some form of letters for this, B and L and or something. So let's do this. We don't want to do more than one letter, not at this stage of our development in these things. So what we want to do is pick a letter and stick by it. So what I'm going to do is the following. Now, this is the hard part of the problems. I use the letter X to describe how many colleges Bolin applied to. Now, the hardest part of these problems is to use the same letter of X, the same letter X, same quantity, to describe how many colleges Lilling applied to.
So X minus 3.
That's right. Because Bolin applied to 3 more colleges than his sister. If he did X, then she must have done X minus 3. Now, after you get the notation down, then you should be able to write some sort of a solvable equation that will give you the answers. So do you understand now? Once I figure out the value of X, I will know both Bolin's age and Lilling's age, once I know X.
The schools they apply.
The number of schools they applied to each. You guys agree with me? Once I know X, I know these two numbers. All right, now, this right here is where we're going to get our next equation from. Can you give me an equation using the letter X involving the 13 schools? What would you set up?
Oh, X plus parentheses X minus 3 equals 13.
So we've got, this is the number of schools Bolin applied to. And these are the number of schools that Lilling applied to. So there's Bolin. Right there. Lilling. How many schools total? 13. It was not necessary to put the X minus 3 in parentheses, although it would be wrong. Now from this, solve the equation. What would you do next?
Add 3 to each side.
I would do something before that.
Oh, 2X?
Right, I would combine my like terms. Remember, the very first stage of solving an equation is to simplify each side. So I'll simplify each side. I get 2x minus 3 equals 13. What would you do now?
Add 3 to each side.
Now you're ready to solve. That's right. So add 3 to each side. And it looks like we get 2x equals 16. Now what should I do?
By 2 by each side.
Divide each side by 2. So now we know that Bolin applied to 8 colleges. And how many did his sister apply to?
5 colleges.
5 colleges. All right, so what we had here is I had a question that asked me, it said, it described one in terms of the other. And then I did something with those two quantities to solve the problem. But the very first part is crucial. Getting both of these items to use the same letter X in their description. Okay, once you can do that, that's the hard, people have said this for years with word problems, but I take it, you know, that you probably are, if you're like any other students, word problems are not your favorite. They're pain. But this is part of describing and transcribing it to the page. Students will often say to me, like, the equation was so easy, but that's right. The hard part is making that, get that equation. And that's what we're gonna try to do. So all of our work involved two things. Using some sort of a description, using a letter. And on the second part, solving the equation for the answer. So it's generally two steps like that. You need to be specific here and tell yourself what is equal to what, like we did right here. This is very helpful. Because once you have that, the question is pretty much done. Oh, did you guys get it all? Did you guys get it all yet? No. With that then, I'm going to give you one to try. You're correct. How did you do it?
Did X.
Okay. That's okay. Tell me what these are. Okay. Okay. It'll help you later on when you go back and do these things. Did you guys ever see the old laptops? They were the size of the English Oxford Dictionary.
I like the, one at the elementary school where they're, well, they were like the.
Mine now, I can hold it on the corner of my fingers, you know?
Yeah.
So
Yeah, it had one, it wasn't even color, it was just, it was, LCD. That's how old it was.
So do you put X minus 13.9 equal 18.1?
Well, let's see here, does anybody, what did you get?
4.2 pounds.
How about you guys, 4.2,
No.
4.2? All right, let's see here. It's the same type of problem. We have two things to determine, because it says how much, find the weight of each computer, right? So we have the Apple MacBook and the Apple Macintosh Portable. So I guess I'm gonna do the MacBook and the Portable. For now, you don't need to be tricky and come up with letters specific to the problem. X will do for everything in this thing. You're only gonna have one letter to deal with, so X you can deal with. So which of these do you want to be Xable? It doesn't exist. That was less than. Nobody, it doesn't know, it didn't tell you. It didn't tell you anybody was 13.9.
It was about 13.9.
No,
Just less than.
Or less than.
it's, yeah, 13 point less than the Apple Macintosh did. So if I were to call this one X, for example, what would this one be?
X minus 13.9.
See, the MacBook weighed 13.9 pounds less than the portable, 13 pounds. Oh, and this should be X plus 13, right?
Oh.
Yeah, that's what I'm saying.
If you choose this to be X, this has to be X plus 13. If you choose this to be X, then that has to be X minus 13. But you do have options, so you don't have to do, they don't have to be done this way. Now, find the weight of each computer if they weigh a total of mean sum, right? So this last sentence here gives us the equation we see. Let me go here and put it here. We have the MacBook plus the portable equals a total of how much?
18.1.
18.1. You can see we're in the same spot as before, aren't we? Once I know the value of X, I will have both answers. So this was the MacBook. And over here is the portable. So tell me, what do we do next?
Put two X's together.
Right? It's almost identical steps, isn't it? Okay.
This is subtract 13.
Oh,
It's 30.9.
thank you.
13.9.
I did the problem in my head before I did this, right? It's like, wait, this is not computing. All right, 13.9. Let me get them all in. 13.9. All right, then what are we gonna do?
Subtract 13.9 from each side.
Should have stayed in the hospital. Then what do we get? 2x equals 4.2?
Yep.
Then what?
2.1 equals X.
Divide by 2. So, MacBook. MacBook. Where'd you go? That was equal to 2.1. Pounds. I had a teacher, did you have a teacher in school, like if you didn't do that, they'd give you like no credit?
Yeah.
Or if I didn't put my name on the paper, I get 0 credit for this? exactly they trying to teach us by doing that stuff? They have to do it your way, you have to do it. Let's see the other one. The other one, portable. That's gonna be 2.1 plus 13.9. And that's a total of 16 pounds. So together they do add up to 18.1 pounds, don't they?
Like they check it.
Yeah, exactly. That's what you want to do. So this plus this is 18.1, so that's a perfect way to check it. So these all were similar in type. Did you notice that? Both of these problems were similar. We described two quantities using one letter, and then we had something involving the sum of those two quantities. Okay, so you have a selection of problems that are similar to this when you go to do the homework.
We okay? All right, let me go ahead and find another problem type. So I'll do one with explanation, and then we'll have you try one. This is another style of problem.
We put X. That to 40 inches.
Right. That one, right, so what's the other one? So we're going to do right. Usually.
I mean, how we put X.
The one, so we're gonna do two lanes, right? We call one X, how much is the other one?
It says 40.
That's total, that's a board.
So
So if you're taking the board, cutting it into two pieces.
it's total.
Right, so let's go ahead and do that. No, nobody said it's cut into two equal pieces. Did it?
Let's cut it into two pieces.
Right, one's smaller than the other, it actually said that, doesn't it? So they're not cut into 20. Here's a picture, a visual representation, let's say this is the board, okay? I'm gonna make a cut point right there, let's say. Okay. You see that there's a longer board and a shorter board, aren't there? What would you call this one and what would you call this one? So what would you call that length?
Just shoot.
What do you want to call it? All right. Tell me the length of the longer piece.
What I'm calling.
Use that letter to do it. Well, a little bit more.
Time.
So
2x.
it says that 8 inches shorter, right? So this must be at plus 8. This must be the longer one, right? 8 inches longer. How much does this total add up to be? What's the total length from this end of the board to this end of the board? 40. 40 feet, right? So that means, is it inches? Oh, yeah, I see. Oh, I will pull this assignment out, I got 0 on it. So then you can see, based on these two pictures alone, you have x plus 8. That's the short board and the long board, equals how much total? 40. And so we put these two x's together, so this problem is exactly identical to the previous two problems. Now what do you do?
Minus 8 on the side.
Subtract 8 from each side. We have 2x equals 32. Finish it off.
X equals 16.
X equals 16, so we divide by 2. So give me the two board lengths then,
16 and 24.
16 and 24. So x equals 16 inches. And x plus 8 equals 24 inches. Certainly your two answers. Okay, so far, all three problems have been, mathematically speaking, all three problems to me are identical. There was nothing, we did nothing new to do any of the problems. They were all the same concept. Let me give you a board one just like this, see how you do. See, while the problem, technically speaking, is different, it's not really different. They just say this is solve problem involving length, whatever. I'll give you one that's a little more complicated than the ones I just did. Do you think I should not jump forward? Think I should just do exact?
Stay what she said.
Okay.
I'm just.
I want you to have a chance of doing your homework. Put it here so you can see what I did on the other one while you're working this one. So this is a pipe that is cut into 3 pieces. That's right.
Are we still only using one variable?
That's correct.
We got, yeah, or, right, that, right. So we'll talk it out in a minute after we've got it written down.
Can I scroll up to get rid of the previous problem?
Did any of you guys leave your computer charger here? This is laying on this case. All right, before the rest of you guys do this problem, let me ask you this. As you're reading for it, how many quantities are they asking you to find? Three quantities, right? So do me a favor, on your paper, list short, medium, long, right? Short, medium, long. You don't have to, you got it right. Unless you want to do it.
Might as well, I see it.
Yeah, so short, medium, and long pieces. Now decide something to be X. Now, there are nicer choices than others when you choose your X's. Pick something to be X. Of those three quantities, one of them can be X. Pick one. Or, right, put it in the short one. Now, read through the problem. Does this describe the medium and the long one in terms of the short one?
Medium size would be 4 feet long.
You can write that. What does that equal then? So using letter would be what?
You can multiply.
No, that's not what long means.
Add.
So you're gonna add 4 to it, right? So what's that gonna look like, that one?
It's going to be X plus 4.
That's right. And now look at the long one, see how it's described. So what does that look like?
X plus 4.
No.
Here's a long piece.
The longest piece is what? What does twice mean?
Times
I know, but what number times twice? 2, thank you.
2.
So what is it gonna be? What are you gonna write there for that one?
X times 2 plus 4.
Where are you putting the +4 from? It didn't say twice +4, did it? It just said twice as big as the shortest, didn't it?
So 2X.
Yeah, 2x. So you've got your 3 descriptions, right? We have x, we have x plus 4, 2x. Now. Oh, here we go. Can you set up an equation now based on what you read in this?
We get 3 times. No, okay, we have 3X, so.
Tell me in detail, what are you writing down?
Is 2X. 2X times 2X.
Total is 24 people. What do you do? Multiply or add?
And
You add those 3 quantities because they add up to how much?
2.
Go ahead and set up your equation. You add those 3 things up, it adds up to 24. I would have drawn a picture myself. But you could have done the same kind of thing. You had a short piece, a medium piece, and a long piece, right? There's a medium one and then a long one. X plus 4. 2x. And this total length is how much?
24.
Tell me the equation you set up.
What was your equation you set up?
So we did a light turn, so we did.
Well, yeah, show me the equation. I have not shown me that is not an equation. The equation has an equal sign in it, numbers, letters. Where's your equation? No.
This is true, so that's been,
Yes.
it's 2x plus 4.
So far, and you're adding three pieces together, aren't you?
Equals 4.
No, why do you keep saying it equals 2x? You, for some reason, you want this plus this to equal that. When you should want this plus this plus this to equal that. So here's a small piece. Here's the medium piece, and here's the long piece.
Okay, I got it.
Now you can combine like terms, so get 4x plus 4. Great, 4. So I get 4x equals 20. And divide by 4. So x equals 5. Here's my breakdown. If this piece is 5, how long is the next piece?
9.
9. These are what, feet or inches? Feet.
Yeah.
The next one is 9 feet. And then how about the last one?
10.
10. 2 times 5 is 10. Now let's check to make sure we got it right. Do these three pipe lengths actually add up to 24? Yeah. 5 plus 9 plus 10 does equal 24. So you should be able to check yourself on these problems by doing something of that nature.
So the medium x plus 4 is, if x is 5, 5 plus 4 is,
Yeah, you might want to make yourself I told you before, write more details and you'll do better. So this X is the small one, this X plus 4 is the medium one, and this 2X is the large one. You want a stress ball? Sure. It was for another student, but I can get more of these things, so. All right, so we have our three lengths here. Can I move up or are you guys still writing? We're good? Are you good? Okay. Let me go ahead and grab another style of problem. How many they got all together? Goes up to 50. All right, oh yeah, I could probably get through that. These are annoying to students at first, but then they end up being friends with them. After you see it's a trick. I'll show you what it is. Now, there's an interesting thing here in the course, in this course. You guys realize that this course that you're taking here is typically taught to like ninth grade students, right? Or eighth grade students, right? I mean, yeah, your math but that doesn't mean that I talk to you like you're 12 or 13-year-old. So I can use adult language while describing the math. So there's certain words that come up often, like consecutive. I don't need to define it, but you know what that means. You know, so do just like we did before. Let X be, so I'm not going to give you much direction right now. Let X and only X be used to describe these two quantities. Okay? Has everybody written it down? You'll at least have it written down? Okay, give me an example of consecutive odd integers.
13, 15.
13, 15, 15, 17, 17, 19. So if I call the smaller one X, how much is the bigger one?
12.
Don't forget about what the problem says. I'm just talking about consecutive integers. If one is called X, what's the next one called?
Y.
No,
X
use
plus 2.
X plus 2. Don't they jump by twos? So 13, 15. 13 plus 2 is 15, isn't it? 15 plus 2 is 17, isn't it? That's the way it works. So if I call the smaller one X, the larger one will be X plus 2. Or if you call the larger one X, the smaller one will be X minus 2. So it's the same idea that we've been using throughout this whole thing. So what I would do is probably say, I would do a smaller and bigger. So it's smaller. That's going to equal X, and the bigger equals X plus 2. Are we good? The integers jump by twos because you're talking about odd ones. What if it just said consecutive integers? Some of the problems do. How would that be different than this? Well, they wouldn't go by twos. When they consecutive integers, what would the next one look if the first one was X? Plus 1, X plus 1, because you only jump by 1 in consecutive integers. You guys understand? But now, if it said even, it would work the same way as the odd. Because the evens also jump by twos, don't they? Zero counts as even, by the way. Yep. All right, now where the equation is right here. This is the equation. I've underlined the equation. Can you tell me where the equal sign is in that equation?
X plus X plus 2 equals.
All I want to know is where the equal sign is. I don't need to sign on that. So
Hey,
I just wanna,
don't be.
I just wanna know where the equal sign goes. Tell me where it goes. Look at that line that I drew. It's in there somewhere.
One third in front of one third.
I mean, it will be in front of 1/3, but that's not all. There's more to it than that. Where is that equal sign at? What word means equals?
Then,
That
more than,
no,
is,
Is.
that's equals.
I knew that.
I didn't,
Is goes right here. You see that? This is helping you build the equation. You now know where the equals goes. Now on the equation, what do we have? We have a left side and we have a right side. Can you tell me what the left side is of that equation?
x plus x is 2.
No. What comes before is?
1.
The smaller one.
Oh, so it should be x.
That's just x, isn't it?
Yeah.
Is, tell me what this stuff looks like. What's 12 more than? 12 plus, then finish it off with this.
1/3 x plus 2.
That's right. I have to put the x plus 2 in parentheses though. Since that is the whole deck one. So let me go ahead and put them in. 12 plus 1/3 times x plus 2. This is a more difficult style of equation than the kind that we've had before. Do you remember how we attacked a problem like this, an equation like this? Well, you might have done it differently than I did, but I tried to avoid the fractions.
When you said you can multiply.
I can multiply everything by 3, and it will wipe out the 1/3. So I'll have a 3x. 3 times 12. And then over here, make it a 3/1, so the multiplication behaves nicely. This is why I think it's so crucial to keep your equals lined up. Everything is keyed around the equals. Here, that can save 3x. That's not a big deal. 36. I dropped the parentheses because I wiped out the 1/3. Can you tell me what you do next?
Divide by 3.
Not yet. You gotta do some cleaning up before.
Oh, add the 6 to 36.
6 to 2 to the 36. So I have 38 plus x.
Yep.
Equals 3x. Can you guys tell me what the next step is?
Subtract x.
Subtract x. You want x's on one side and the numbers on the other side. So if I subtract an x, the x will disappear from the right and only appear on the left. And finish it off, divided by 2, what do we get for our x?
16.
Try again.
Oh.
There's 2 reasons why that answer is wrong. For one thing, what kind of numbers are these supposed to be?
Odd integer.
You just gave me an even.
It's gonna be 15 to 17.
No, let's divide by 2. Divide by 2, hey. I get x equals 19.
Oh, that's bad at that.
So that, what does that make the other number then?
17.
No.
The
Small x is
smaller is
minus
that, so it would be 21.
21, that's right. Two numbers, 19 and 21. Now, should we check ourselves to make sure it actually did work? This business right here, this 12 plus 1/3 of x plus 2 is supposed to be equal to the smaller one. Well, let me check this stuff out here. So there's my equation, so I'm gonna replace X with, what was our answer, 19? 19. All right, so I'm gonna check this equation. Check my answer. Check 19 goes on the left, that's where the X is. Over here, we got 12 plus 1/3. What is X plus 2 then? If X was 19, X was 21.
So 7 plus 12.
12 plus 7, indeed, equals 19.
That has been checked.
So remember, consecutive even or consecutive odd integers are gonna jump by 2 units. Just plain old consecutive integers will only jump by 1 unit.
Can I scroll up or no?
Yes, definitely.
I'm just gonna give myself enough space to put a thing down there. There are a couple things too. Whatever your answers you get, we're not gonna try to trick you. They should make sense. So your answers should be sensible given the problem in hand. Can I scroll up? Are you good? Did you catch up with it? Okay. I don't, do you want me to keep that up there so you can see maybe how to solve this one? Or do you want to do it solo? All right, give it a try. That's good attitude.
Straight on 7,000. And
If any of you ever in any kind of delivery, you know they put the evens on one side and the odds on the other.
we'll start explaining.
See anything in it?
I'm gonna hold off on explaining. I want you to take a couple minutes. There's a basic rule in math that goes like, you can be successful at math. There's two ways to do it. One is to be a genius. Two is to persevere. That's the path I've chosen.
That's right.
Like I did in the first, do me a favor here. Do this. Say, first house, second house. So write that down, first house and second house. Now use the letter X to describe those two houses. Not the exact same letter X, one X will be involved in both of them.
The first one says X, second house. X plus X.
No. How much X plus, it's not X plus X. How much do they jump by?
Two,
2. So it's not X plus X.
X plus two.
Right. Change that X to a 2. So your two quantities are X and X plus 2. Now, it gives you an equation in the problem that you can solve. They have asked us to, whenever we do something, to relate that to you, that you're being taught something, and you wouldn't know it unless I tell you. This is critical thinking. You've heard the phrase before, right? Everybody wants critical thinkers. Well, knowing what parts are relevant to the problem is a skill that requires critical thinking. I have underlined the part that tells you how to set up the equation. It literally does. You use the things that I've underlined to, so let me put the small, let me see.
You got two competitive positive numbers and policy on the second one.
You know, I do this. That wasn't well thought out at all.
Put it right there.
No, I mean, you're gonna see this thing, especially if that way is big. So that's much. All right, two consecutive house numbers added. So we have the smaller one. A larger. X and X plus 2, just like you said. Now, can you tell me, using those things, what this underlying? How is it? Not even focus. You're being back. What does total mean?
Okay.
Or no, I'm sorry, add up. What does add up mean? They did not even use the word total, are they? They're literally using add.
Yeah.
So can you tell me an equation then?
Two X plus two.
Well, and you're getting there. So we're gonna get, so the smaller one, say it as you write it. The smaller one
Is X,
plus the larger one adds up to how much?
74. 46.
How do you solve it? What would be the next step?
So it's combine the next.
Try to combine, right? So we're gonna get 2x plus 2. This is what you did in one step. Okay, now,
You, subtract two. From two, minus two, and the same on the other side.
okay,
Now you do, 2X, you cancel out 2X.
don't forget, you're allowed to use your calculator.
On both sides, okay.
3722, I believe. Check that out, make sure it actually works.
Yep.
That it, 3722. Now, don't even worry about this, because now you can just list the two consecutive integers. We've got 3722. Just tell me the next one. 3724. Yeah. All of these problems have shared similar strategies, all extremely similar strategies for solving them. Did you notice in every single one of these problems, almost every single one of these problems, you took the quantities and added them together to get a new one, and you solved.
whatever equation resulted. I have time. I think I have time to do one, not to give you one, but to do one. So with that, I want to grab a different style of problem here. Oh, no, they don't have a different style of problem. Then which of these three types of problems would you like me to do one real quick? Integers, lengths of rope, what? All right, I guess I'm choosing integers. I'll do 32. So I was able to do all the objectives for today's class. Okay, so as before, it says find three consecutive integers. Three consecutive integers. Can you tell me what they would look like if you're using the letter X to describe them? What could the first one be called? Yeah, you're free to choose X. The next one after X, what would it be? Consecutive.
Two.
No, that's not, no, plus one. Then what would the next one after that be? Because you gotta do three of them.
Two.
This is consecutive even integers, so.
Oh, yeah, I didn't see that sheet. You were right, absolutely. I didn't see consecutive even integers. So we have X and X plus two. Can you give me the next one on the list?
Four.
So we got a description of our letter, our three numbers. Their sum is 12, so their sum is, let me put the equals down here. Their sum, that's this part right here, is going to be X plus 2, X plus 4, is 12 less than twice the smallest. The smallest is X. That's 12 less than twice the smallest. I'm giving you the rest of the assignment to finish this problem. Okay, not right now, maybe next class. So that's all I have for today.
I see you there, right?
Yeah. Let me do it real quick.
Okay.
Let me see what you got. Yep.
Sweet, thank you. Thank you for the class.
Sure, no problem. They actually paid me to do this, you know that?
Pay me to do this too, so.
Oh, good. I'm glad everybody's being paid. I love it.
See you Tuesday.
See ya.
If they pennies are two.
Yeah, gotcha.
I don't know why I did that. That's wrong.
All right. So
My lessons, there we are. Daily notes. Today was 2/6. Go ahead and stop this. Stop the recording.